Dear students and participants, I welcome you back to the lecture series on the railway engineering course. Today, we are going to start with the joints, and in this lecture, we will be emphasizing on the types and the requirements of the joints. In the previous lecture, we completed the various types of stresses which can be there in the different components of a track. We started initially with the rails, then we talked about the sleepers, and then the ballast and the formation which were taken in the previous lecture itself. And then finally, two other things which we discussed there was the stresses in the fish plates and the bolt holes, as well as the dynamic overload. Now, in this lecture, we are going to talk about the joints first of all in terms of what are the effects of the joints in positive or negative form, what are the requirements of the joints which should be there when they are provided at any of the location, what are the locations where the joints needs to be avoided, and then how these joints can be maintained. Just after that, we will be starting with the various types of joints, and these types of joints they have been defined by the type of position on sleeper as well as the type by position on of rail joint. And finally, some of the special joints will be discussed. So, let us start with the joints. Now, this is a location where the rail ends are jointed. If you remember in the last lecture, we did talk about that because we were talking about the fish plate and the fish bolts which were used to connect two of the rail sections together. So, this is a location, this is a rail joint. So, we are connecting them here. Now, these rails are connected by using a plate with holes in it. So, it is like this with the holes in that. So, this is a fish plate and these are the fish bolt holes. So, they are connected by these and the bolts are used to attach the plates to the rails. So, you will be having a bolt being placed here. Similarly, a bolt is being placed on this one. Now, the another way is that we just weld the rails at the ends. That means, if we are welding the rails, then some material will get filled here and we will get a continuous surface. So, this is a welded condition. The joints can also be insulated or they may not be insulated depending on whether there is a requirement of circuiting on the track or there is a requirement of isolating those things. So, in that case, if you are going to make it insulated, then there will be some extra things which will be provided which can be discussed further. Now, a perfect rail joint is the one which provides the same strength and stiffness as any other section. So, whatever other sections are being there, see the one rail section at the middle level is there. So, whatever strength is there of the middle section, the same should come on this joint section. Otherwise, this joint section is going to be a weak point on the track. And it is a weak point on the track because not exactly the same value is going to be there as it is in the case of the normal section of the rails here. So, this is an important aspect. Now, what are the negative points with respect to the rails? Now, because it is a joint, a continuity is being broken here. So, in the vertical and the horizontal plane both this continuity has been broken, and as soon as it has been broken, it becomes the weakest point in the track. And the strength of this rail joint is half the strength of the rail. So, this is an important point which we were talking there, that though we should try to make it in such a manner that the strength remains the same as the normal section of the track, but it is not happening. It is half of the strength of a rail. Wheels of a locomotive or a wagon on a joint may face a jolt while traversing the joint. So, why this jolt can come? There may be a possibility that these joints which have been created, there is some movement, a very small movement which at the moment will not be possible to identify, but there is a difference in the level, and when the wheel moves here, then it will strike at this location and then shift like this. So, you must have felt that when you have traveled in a train, some sort of a small jerk comes, and that small jerk may be coming at the locations where the joints have been provided. Now, blow of wheel and flange may cause loosening of the fish plates or the ballast packing or the fastenings, because here when you are talking about this and when you convert it into the form of a rail section, and then there is a wheel with a flange. So, if this lateral movement is there, because of this lateral movement, what are the fastenings which are provided at the bottom or being provided at this particular location, say in terms of a fish plate or a bolts? Because of this striking and the jolting which is happening here, they may get loosened slowly and slowly. Then the blow of wheels may also cause the distortion in the geometry of the track, and it has been observed at some locations you may find the track has gone in this form. So, a distortion has come into the track, and this distortion may be at such locations where the joints are provided. Then around 30% more labor is required to maintain the rail joints. So, it means it has a cost component and it has the manpower component which we need to take care of. It is increasing here. There is heavy wear and tear of the track material. This is another issue which will be there at the joints, and this wear and tear can be in terms of the rail head. Here it can be in terms of the sides. So, this wear can appear at any location. Then extra stresses get caused at the rail joints, which affect negatively the lifespan of the rails, sleepers, fastenings, etc. So, as and when there is a impact, that impact load is going to be more than the static load. So, it will create more issues in terms of the higher stresses which have got induced at that particular location, and if this becomes a repetitive nature, then in that case the lifespan of the various components which have been used at that location is going to be down. There are higher chances of the rail ends which get battered. So, if we talk about that, so it means it gets battered in this form. So, it may remain here as like this, but there is a down movement here. So, the battering of the rail can be there. So, it is also termed as hogging. Then the rail fracture due to fatigue stresses at the rail end. So, these are the distresses we will be talking at some point, that what are the various types of wears and distresses which can get induced in the rails at different locations. There is a lot of noise which gets induced with the interaction of the wheels and the rail joints. So, this is also another negative issue which is disturbing for the passengers. There is a potential danger of removal of the fish plates, or there is a chance of the failure of the fish plates. The fish plates may start cracking. Say if you are talking about a fish plate which has 2 bolts here and 2 bolts here, there is a possibility that cracks may get induced on those locations. The quality of track lowers with all negative impacts as mentioned above. So, this is another big maintenance issue. Rail joints also increases the fuel consumption because of the extra hauling effort at the joint. So, this is also a problem. The fuel consumption, if you are talking about say a diesel locomotive which is moving on that particular track. In the case of electric locomotive, then this fuel consumption as a direct commodity is not there. There are positive points also. The rail joint allows the manufacturer to manufacture the smaller lengths like 12 meters and 13 meters. We discussed at one point of a time that we are now looking for the welded systems, and these welded systems, they will be 10 rails or say more than 10 rails likewise. So, there can be a these are defined as the long welded rails, or there can be continuously welded rails. The handling effort is lower if the lesser length rails are used. Cost of handling is slightly lower as compared to handle the longer length of the rail. So, what are the requirements on the basis of our understanding of the positive or negative aspects related to the joints? The joint fittings shall hold the rail ends for the continuity and reduce the possibility of the wheel jumping and deviation. So, whatever the joints are being designed, they should provide a continuity. That means the gap which is provided here has to be adjusted in such a manner that it does not gives a feeling that when the wheel comes at the top of it, it simply bridges very easily and does it gives an idea that now you are jumping on a joint. So, this type of a jumping issue should not be there. The joints shall have sufficient strength and stiffness, and that strength and stiffness is provided either in terms of the welding of those rails at the joint or providing the fish plates with the bolts. Adequate expansion gap shall be provided for the thermal effects. So, at this point whatever gap, this gap has also to be looked at with respect to the thermal forces, and these thermal forces may induce expansion or contraction. So, there is a positive or a negative movement here. So, if it goes beyond, so the gap should be such that whatever that movement is, this should not happen that as soon as the expansion has happened, then this gap is being closed, and when it closes, then there is always a possibility that due to the higher stresses, now the joint will look like in this form. So, a kink may get created at this particular location. Then fittings shall allow for easy removal and replacement. Whatever the type of things which we are using at this joint, they should be such that we can very easily remove them and replace them if required on the basis of the maintenance records. Adequate flexibility with use of fastenings shall be present. So, there are different type of fastenings which are available, and not only we are connecting this two of the rails like this, but at the bottom also the rail is going to be connected with the sleeper. So, there should not be an interference of say the fish plate versus the fastenings which are provided between rail and the sleeper. And then the types of fastenings can be the conventional fastenings or they can be the elastic fastenings. So, if we have these different type of fastenings, everything should be able to fit in very easily. Then provision for wear at the rail ends shall be made in the rails. So, this is aspect because you cannot remove the wear totally, there is going to be a wear on the with the passage of time with the movement of the trains at that particular location. So, you can make some allowance for that. The joint shall work with adequate elasticity, it should not be a very rigid joint, and that is where when we use these fish plates there with the bolts being inserted, there is some gap which is provided extra, so that if there is a movement of the rail, then this movement of the rail is being allowed. Otherwise, if this is a gap say of the hole is of 2 mm and you are providing the bolt also of the same size, then there will not be any possibility of the movement. So, the tightening of the bolt as well as this size of the hole with respect to the bolt size, they are not same, there is a bit more as compared to the diameter of the bolt. And initial as well as the maintenance cost should be low, the cost component also needs to be taken care of. Now, what are the locations where the joints should be avoided? At the level crossings. Level crossings means you have a track and then there is a road here which crosses, and this is a gate being provided here. So, at this level crossing, the rails, they should move continuously, it should not be a joint here. In the case of the short bridge spans of any type, there also on the bridge the joint should not be there, it can be before, or if at all it is required, then again there is a value being given. So, in the case of approaches of the bridges, within 3 meters of the bridge abutment it should not be there. So, if you have a river and a bridge has been constructed here, so there is an abutment at this point or abutment at this point. So, any joint which is being provided, say this is a rail, so joint is provided here. So, the distance between these, it should be more than 3 meters. Then at the end or near the center of the long bridge span. So, at this particular location or at this location, we should try, it should not coming, but if it is provided, is at a point located at 1/3 of the span length. So, whatever is this span length is, that is L. So, the joint should be at L by 3. So, that means there can be a joint at this position or there can be a joint at this position, but there cannot be a joint along the center line at this position. Now, talking about the maintainability, how can this be maintained? On comparison of the stress produced in rails and fish plates, the wooden sleepers could be considered as the best type of sleeper for the joints. The reason being that they can absorb the stresses also. So, one point is that we can use the wooden sleepers at those locations where the stresses are going to be more. And these wooden sleepers then will help in producing the low stresses in the rails as well as in the fish plates, and they will put up the good performance from the point of view of deflection, maintenance, cross levels, etc. If we are not going with the wooden sleeper, then the another choice can be as CST9 steel sleeper or a duplex sleeper. They are also good at these particular locations. So, if you remember at one point in time we were discussing about the sleepers, we said that there is a possibility of a combination of the sleepers, and this is what is a combination of the sleeper, that on all of the track you have used say the concrete sleepers, but when it comes to the joint we may be going to the wooden sleeper, we may be choosing CST9 or the steel trough sleeper or the duplex sleepers at that location. Now, from the point of view of good track maintenance, the duplex sleepers are found to be very good, but they are hard on the rails. That means now the interaction with respect to the rail, there is a possibility of more stresses getting created and the wear taking place at the rail seat. Now, if some suitable elastic pad is being provided, then in that particular case the duplex sleepers can be provided with a suitable joint support. So, elastic pad, because in this particular case then this hardness and the interaction of this hard interaction between the rails will not be there, and these duplex sleepers no doubt produce the minimum deflection. This is also a positive side with respect to the duplex sleepers. Then in the case of fish plated joints, these will have the wooden or the concrete sleepers. These are the two possibilities, and the spacing of joint sleeper would be 300 mm for wooden sleepers and 340 mm for the concrete sleepers. The spacing of joint sleeper means, so this is a joint being provided here in the rails, and there is a sleeper at this point and there is a sleeper at this. So, this is defined as joint sleeper. So, the spacing between the joint sleeper is what we are talking as 300 mm or 340 mm. The wooden sleepers would be provided with rail free fastenings. Now, if the rail free fastenings have been provided, in this case, say the canted bearing plates with the 4 screws, then the stresses will get reduced. The concrete sleeper at joints should be provided with the elastic rail clips. This is elastic rail clip for joints. So, this is for the concrete sleepers. Now, at the welded joint and glued joint, this can have the normal sleeper spacing, because now this is a continuous track, there is no such joint available now. And in the case of the defective welds, and these defective welds, they are being defined by their categories. So, here we are talking about a defective weld category 1, defective weld category 2. These shall be provided with the joggled fish plates. Now, when we will take up the fish plates, we will come to know what is this joggled fish plate. This is a bit different than the fish plates which you are using as a standard medium of connecting the two rails, or the third one can be a combination fish plate. Now, maintaining these joints in terms of the lubrication, how this lubrication can be done, and this is very important because this allows the fish plates and bolts and rails to have a relative movement. If it is not being done, then this will become hardened, and when there will be expansion or contraction because of the thermal variations or temperature variations, then there will be more stresses at those locations, and that will be harmful. So, it facilitates the expansion of the rail, and to retard wear on the fishing planes of the rail and fish plates, this lubrication is required. Now, what type of lubrication can be done? It is a thick paste of graphite and kerosene oil, and this is used in a ratio of 3:2, and then that is being placed. There is also a possibility of use of black oil or reclaimed oil, and this is used for oiling the fish bolts and the nuts. And lubrication is done once in a year during the winter time. So, during the winter, because the temperatures are going down, so at that time if the lubrication is done, that it will remain for a certain good period or a longer period, and after that as the summers will be there, that whatever these oils or kerosene etc., they have been used, they will obviously melt because of the temperatures, and it will come back into the good lubricated condition. So, that is why during the winter this needs to be taken care of. Now, let us come to the various types of the joints which can be there. They can be as defined by the position of sleeper at roll joint or a position of the rail joint, insulated joint, special joints, welded joints, then they are the other things. So, let us start with the first one. According to the position of sleeper at the rail joint. First is supported joint. As you can see in the figure being given on the right hand side, there is a sleeper 1, sleeper 2 and sleeper 3. So far what we have been talking is that the sleeper 1 and sleeper 3, they are the joint sleeper. This is the normal practice which is followed. But in this case what is done is a sleeper 2 has been inserted just below the joint, and as soon as this is being inserted at this particular location, so whatever the weaknesses which have been there in the joint itself because of the discontinuity, because of no material available at that particular location, that has been given a support from the bottom. So, it provides the support directly on a sleeper, the rail end is falling there, and this becomes, but one thing which happens as soon as you do this, there is a possibility of the rail head going a bit up. So, this is becomes slightly high. The wear and tear of the rail end, it is going to reduce because now it is not a unsupported system, whatever loads comes, whatever the impacts which are going to be there at the end of the rail, these impacts will not induce that much stresses that the loosening in this area happens, and as soon as that loosening happens, then the wear and tear will increase. So, because of this supported system, that reduces here. And similarly, the wear and tear of the sleeper is also not going to be that way. Maintenance is a problem because packing under the sleeper, they may get loosened after a certain period of time. So, this is one thing which will need to be taken care of. Now, duplex joint rail sleeper is an improvement over the joint. So, this we have discussed, that what are the advantages of using a duplex joint rail sleeper. Then the normal condition which will be there is that with respect to the rail, there are sleepers which are provided, and those sleepers are known as the rail joint sleeper. But when this is done, there is a unsupported area here of the rail. It remains in the form of a cantilever. So, this portion which is not being supported because of the loads, and because if the packing at the bottom are not good enough, then in that case the wear and tear in this particular area may increase. So, the problems of loosening of packing at joint due to hammering action of the moving loads can be there, and there are sub portion of the rails that remains, as I said, the cantilever beyond the sleeper, but then still this is one of the most commonly used type of a joint system. Another is a bridge joint. In the first one, what we talked about was that a support has been provided in terms of a sleeper itself. But here we are not using a sleeper. We have the joint sleeper here 1 and 2. But these two joint sleepers, they have been connected by either a metal plate. This is a continuous metal plate which is being provided, is being inserted into the sleepers and gives a support to the joint just touching the rail at the bottom, or it can be in the form of a arch. So, whatever load which will come at this point because of the interaction of the wheel with the end of the rail, that load will get transferred to the sleeper here, or in this particular case it is being transported from using this particular bearing area. So, this is usually used at those locations where there is an issue with respect to again and again the problems of the rail ends, their battering or hogging or the dipping of the rail end. So, in those stages we can strengthen it by way of use of these metal flats or the corrugated plates as a bridge plate. Now, according to the position of rail joint, now one is the square joint. A square joint means there is a joint here, and just in opposite to that there is another joint on the rail which is parallel to the previous one, and this is one of the most common arrangement. So, the rail length is there, they have been placed, the two rails are being placed together, and then what we get is a joint here and here. This is mostly come on the straight sections, because on a straight section whatever the distance which is being travelled on a inner side or outer side of this track is same. So, if the distance is same, there is no issue. But in the case of the curved section, there is a problem. If you are on the outer side, then the length or the distance moved is going to be more as compared to the inner side. And because of that reason, even if you use the same length of the rails, there will be a displacement here in terms of the two joints which are coming on the two tracks. They will not be in front of each other or opposite to each other, and this is what is being defined as a staggered joint. So, in the case of a staggered joint, the joints across the two parallel rails, they are staggered, they are not opposite to each other, happens on the curved tracks, and this happens due to the length of the outer curve being greater than the length of the inner curve, as I already mentioned, and it hinders the centrifugal force that pushes the track outwards. Now, because the two joints, they are not coming at the same location, so if even if there is a centrifugal force acting here, the another rail is continuous one, even if it passes through this joint, there will not be an issue. Then the special rail joints. Now, one is the base joint. What is it? It uses the flat or the corrugated plate bolted to the sleeper with bar type inner fish plate and angle type outer fish plate. So, we have already talked about the fish plates. Now, fish plates, they are being placed now on both of the sides. So, one is an inner fish plate, another is an outer fish plate, and One is as a bar type. So, when we say bar type, it will be simply like this. Another was is angle type, means a built movement is there. So, there is an angle form is there. Then another is a compromise joint. Compromise joint uses the combination fish plate. What is this compromise joint? Is that you have a rail section being used here, which is say 52 kg per meter, and then you are using another rail section here, which is a bit higher one, say 60 kg per meter. Usually we do not do that, but there are certain conditions in which if it happens, then in this case the levels are going down. Here we have tried to maintain the level, which has to be done because the wheels will be moving at the top of it. So, this level is being maintained, but there this difference will be coming. So, what happens is then here, because this line is also going down, so this type of a fish plate will be there. And this is what is a combination fish plate. Then a special rail joint in terms of a rail free joint, where the rail is not linked with the sleeper. This is a case of a duplex sleeper, but it is dangerous due to the play between the rail and the sleeper. In some of the cases it can be used with some because of its positive nature, but otherwise it is a problem. Now, if we want to remove all of the negative aspects which are related with the joints, then the one option is to go for a welding of the joint. So, we will be talking about the welded joints and the various techniques of doing those weldings in one of the lecture to follow. Now, let us talk about another specific one. This is a switch expansion joint. In short, it is defined as SEJ. Now, these are the expansion joints which are installed at each end of the long welded rail or the continuously welded rail, and they permit the expansion and contraction of the breathing lengths due to temperature variation. So, when the temperature is variation is there, there can be an expansion, there can be a contraction. But if you are talking about this LWR, so if suppose this is an LWR track and this one is a rail joint, this is another rail joint, is going to be more than maybe 10 rails altogether. So, only in some portion at the rail ends there is a movement, and in the central portion there is no movement. So, where this movement is coming, this is defined as breathing length. Again, we will be discussing about this breathing length and how to calculate the breathing length when we will be talking about the LWR and CWR. These usually provided on the same rail sections. If it is provided on the junction of two rail sections, that is, as I said, 52 kg and 60 kg, then the combination SEJ has to be provided. Another important issue can be the joints on the bridges. Few of the things we have already talked, say with respect to the abutment, with respect to the center of the bridge. In terms of a short span bridges, the joint should not be there on the top of the bridge. So, if the case of a small bridge openings which are less than 6.1 meter, the rail joint should be avoided on the bridge. And in the case of the spans which are more than this 6 meters, then the free part position for the rail joint is 1/3 of the span from the end. So, if an abutment is provided here and an abutment is provided on this side and the track is going at the top of it. So, not in the center, not very nearer to the abutments. We have already talked about that if it is coming near the abutment, it should be more than 3 meters distance. Not in the center, but it can come at 1/3 location here or 1/3 location here from the abutments. No fish plated joint should be located on the girder or within 6 meters from either abutment. In all such cases, rail free fastenings such as rail free clips shall be used so that the relative movement between the rail and the sleepers may take place. So, this is a simpler thing, we have already talked about it. So, with this we will close this lecture. What we have discussed is the joints in the rails, the positive and negative aspects related with the position or the provision of the joints, the requirements, the locations where the joints can be avoided or the joints can be provided, what are the various types of rail joints, the joints in terms of SEGs and as well as on the bridges. With this we close it. Thank you and bye.